And here we are again. We're still working on nitrogen, which means our Sesame Street letter of the day is still N for nose and for nitrogen. And without nitrogen, there would be no nose. And so recall with the nitrogen cycle, we've got nitrogen that's changing from one form to the other, and bacteria is the major player that's making all that happen. And it's a tricky cycle, so what I want to do is give you a tool to help you remember how this all goes. And so it's this little mnemonic that's called fix, nad, and pan. Fix, nad, and pan. Like eeny, meeny, miny, mo. You're going to remember it forever because it's gibberish. Here's how it works. You want to write down fix, nad, N-A-A-D, and pan. And one side of this is going to be the process, the other is the product. And so what we're going to do is we're going to start with N2 gas, and it's going to go through fix for fixation. Nitrogen fixation is the process done by bacteria. It's going to turn that into ammonia, which is NH3 or NH4. That's our product. Then that product goes to the next process, which is nitrification, which turns that ammonia into nitrites and nitrates. And now you've got something that a plant can actually absorb. And so the next word process is called assimilation. For all you Star Trek fans, it's not a new word to you, but for others maybe it is. That's basically the plant absorbing that nitrate through water, and more than likely through the soil, or maybe it's in the lake or something. And now the plant turns that nitrate, which is inorganic, into protein, which is organic. That's a pretty cool step. So now it's in the plant's body as protein, or amino acids, turns into protein. The plant basically makes plant material out of it. And animals can eat that plant, or other things can eat it. It's in the food web. That's how we get our protein. And eventually, maybe that plant drops its leaves, or an animal dies or defecates, and you've got protein that's on the ground or out in the environment. And here comes the next process. It's called ammonification, and that turns that protein back into ammonia. At that point, maybe that ammonia is going to go back through nitrification. But just to finish off our thing here, the next step could be denitrification, where you've got a different type of bacteria that turn the ammonia back into nitrogen gas, okay? And then it can start all over again. And so the idea is you could like totally write this down in the margin of your paper on an exam, fix, nad, and pan. And the idea is that you get that first letter. If you can remember fix, nad, and pan and line it up right, that first letter is going to trigger your memory to remember the name of the process that's involved. Okay, so that's definitely worth writing down, and make sure you understand it. So pretty interesting, but it gets more interesting because now we got to bring in the human factor. And so people have been farming for like 10,000 years, and for most of that time, we relied on bacteria in the soil to naturally make nitrogen. But then as the population got bigger and bigger, nitrogen started to become the limiting factor on population growth. Until this guy right here, the guy with no hair, his name is Fritz Haber. And in 1909, he invented a technique that was able to take that nitrogen gas out of the air and turn it into ammonia without lightning, without bacteria. How did he do it? He took the N2 gas and the H2 gas, and then he just used natural gas like methane, and got it super hot temperatures to break that triple bond apart. And I don't think you can read it here, but it says NH3. There's a picture of it. Out comes NH3, and then carbon dioxide and water is the, I guess, the waste product. And so he figured this thing out, which was huge. How big? They say it was the single most important invention in the entire 20th century. It's incredible. They say without him doing this, because basically what that led to was fertilizer, right, or synthetic fertilizer. Without him doing that, 2 out of 5 people on the planet right now wouldn't be here. And so just think about that for a second. So who's this other guy? His name is Bosch, and he just marketed the product. They call it the Haber Bosch Process. I always say Haber Bosch. That's the Minnesota in me, but it's Haber Bosch. And so Haber was a scientist, and you might be like, how come I haven't heard of this guy? He did win a Nobel Prize. Like, it was a huge, huge thing. Here's why you haven't heard of him, because it's just a great story of how people are good and evil and complicated. And this guy is the epitome of it all. He did this thing that changed the lives and improved the lives of so many people. And he was also a bit of a war criminal. He was a Jewish German. And the story goes, World War I broke out, and he just wanted to help his country in Germany. Immediately Germany is cut off from the rest of the world, and they can't get nitrates. Because not only are nitrates good for growing plants, they're good for making bombs. Ammonia and nitrates are ingredients for bombs. And so Germany can't get the stuff they need to make their weapons. And so Fritz Haber steps up, and he's like, I can do it. And he starts making ammonia nitrate in Germany using his process to make all these, to make weapons, which I guess is one thing, but it gets worse because he's a chemist, and he develops a way to make ammonia gas and chlorine gas, both very poisonous. And so I've heard some podcasts that are just mind-bending. And so the story goes, France and Germany are deadlocked. It's a stalemate. They're in like just early warfare in trenches. People are getting sick and dying, and it's just terrible. And Haber is like, I've got the answer to this. And for the first time in human history, they use gas for warfare. And I've heard stories about it. It was just the most awful thing, is this gas crept over France's line, and people are just vomiting and just turning green and dying one after another. Just horrific. And Haber is thrilled because his little development worked. And he gets recognized by Germany, but the story just gets worse. His wife finds out and is just so beside herself. She kills herself with Haber's gun, like in front of their son. Haber doesn't care. He just wants to advance the war. And eventually they lose the war. But then, World War II kicks in. But remember, Haber's a German, or he's a Jew and a German. And because he's Jewish and all of his staff is Jewish, he loses his staff. But he does develop a gas in the meantime that's used in the Nazi concentration camps. And so he is part of that whole genocide too. And finally, because he's Jewish, he's kicked out of his country, and he dies just wandering and homeless. Just like a horrific story. Totally, I don't know, makes you think. The good and the evil and the complications of humanity. Anyway, moving on. At the end of World War II in the United States, we had all these ammunition plants and all this nitrate and ammonia of our own, because we were obviously in the war too. What do we do with it? This is like the war machine trying to convert into like a peacetime kind of activity. They made the decision that we're going to turn this into, we're going to use it for fertilizer. And that was where our big yields started kicking off. And so now we're fertilizing. And it's a big deal, and we fertilize all the time now. And because it's such an energy-intensive process, what we've really done is we've turned a system of growing food from like solar energy into calories. Now it's fossil fuel into calories, because to make fertilizers, you got to have the fossil fuel. It's like 10 calories of fossil fuel to 1 calorie of food. Check out. Here's where World War II ended, and boom, this just goes to 2000, but it just goes off the chart. And now, and actually, this is why China and Nixon got together. China needed the fertilizer too. Look at how much fertilizer use is happening in Asia. We're going to wrap this up. And there's much more to follow on fertilizer, but we've got a couple environmental issues you need to know about. What happens is farmers, you don't want to go light on fertilizer, because what if you do that? Why not use more and grow more food? And so typically farmers over-fertilize, which is all good until you get heavy rains, and that fertilizer runs off and eventually makes its way to waterways. And you're going to read about this in chapter 5, but you get eutrophication, and this is an algae bloom, and it can turn into dead zones and cause huge economic problems. So we're going to wrap it up there. I hope that was interesting to you. I want to highly encourage you to write a summary here for your notes, and flip through some of these other nitrogen cycles. See if you can follow it. See if it makes sense to you, and then we will check in back in class. Thanks for hanging with me, you guys.